Everyone, hi again. Welcome back to another video on Leet code coding series. Today we're going to solve a new problem, that is subarray sum equals k. So it is also a problem based on prefix sum technique. So we have already discussed what is a prefix sum technique through a problem, and here also we will learn more about prefix sum technique. Also in this problem we're going to use a hash map, hash data structures. So if you are in from Java background, so you have to understand first what is a map interface in a collection framework. So right now, what is a problem statement? So here it is given that we have an integer array nums and also an integer k. So basically, we have to return the total number of subarrays whose sum equals to k. So suppose we have nums array like in example 2 as 1 to 3. So these are the nums array. So okay. So this is our nums array. And here we have given k is equal to 3. So what we have to do? We have to find total number of subarrays whose sum equals to k. So simply you can say that 1 plus 2. Okay, so 1 2 is a first subarray whose sum is 3, and only 3 on a single element, that is 3. So that is also a second subarray. So total number of subarray is 3 whose element sum is equal to k is equal to 3, that means 3, so it is 2. So here first you have to understand what is a subarray. So a subarray is a contiguous non-empty subsequence of elements within an array. So here in this example 2, the subarrays are 1 2 and 3 separately, and after that 1 2 and 2 3, and also 1 2 3, but 1 and 3 collectively is not a subarray. Okay, so hope you understand what is a subarray. Now let's first understand what is a prefix sum technique. Also if you don't know, so you can watch it, and if you already know, you have to just you can skip this part. Also you can recap it. So here first of all, our prefix sum technique, we simply build a array. Okay, so we simply build a prefix sum array, or this is nothing but it's a array sum. So what is a prefix sum technique? So in the prefix sum technique, generally we add all the previous elements, okay, with that elements when we wants to calculate sum. Okay, so here we build a prefix sum array. Simply sum array, you can call it at a sum array or also a prefix sum array. So here you can see that for every elements we just add all the previous elements with that element. So for this nums array 10 20 30 50 and 50, our prefix sum array is 10 30 as 60 100 and 150. So that is basically our prefix sum array. And also how can you build that? So you can simply use a technique. Also one thing you have to understand, there are two concepts. Okay, so a lot of places, a lot of books, you can see that the prefix sum basically starts from the index 0, and here it is taken as the index value at 0, the first value at index 0 it is 0. Okay, and they have started from the index 1, the next value. Okay, but I used to took the first value as it is. Okay, so I did not increase the prefix sum array size by 1. I just used the same size of prefix sum array. What we actually do, we simply just replace. Okay, we just simply add, we simply put the first value at the first index of prefix sum. Then after we're going to use our prefix sum formula. So here what we have to do, we're going to use a for loop. Okay, so before writing this statement you have to iterate a for loop from I is equal to 1 to n minus of 1. So after that what you have to do, you have to just write prefix sum I is equal to prefix sum I minus of 1. That means you have already calculated the previous prefix sum plus nums of I. So that is simply it's nothing but it's that current element. So for the value 30 you simply write is 10 plus 20 and 30. So the current prefix sum of this element, like for the third index, is simply at index 2 at position third is 10 plus 20 plus 30. Okay, so why this is basically our first technique. So you have to understand how you build the prefix sum array. Now the question arises, why we build this prefix sum array? So simply, we're gonna use this concept. Okay, so if we have already built this prefix sum array, we're gonna use this formula to calculate the sum, to find the sum between the range. Suppose someone's gonna ask us, find the sum. Okay, so find the sum of elements of this nums array from 2 to 4. Okay, so we have given a certain range from 2 to 4. So this is basically our range. So how can you find the sum if you don't know the technique of prefix sum? You simply iterate a for loop from 2 index 2 to 4 and sum all the array elements. So simply you will add the value 30, 40 and 50. So is it? So so again, so I'm gonna ask you, just you have to just find a sum of from 1 to 3. Okay, so you just gonna use another for loop and just calculate it as from 1 to 3. Suppose think, if array size is very large and we have like lot of array range, so what you will do? So every time you have to iterate a for loop, so it becomes tedious or difficult. Okay, and it's the code will not look so good. So there we have a solution. What the solution we have? We have this technique, prefix sum technique. So we can easily get, if we have already built this prefix sum array, we can get that range sum in order of one time if we already build it. So that is why we're gonna learn this prefix sum technique. So here you can see that the prefix sum of suppose you want to find like what is a j value, it is the upper range value. So simply you can write here 4 and that value is simply, that value I is simply the lower range value. Okay, so here just write that value as 1. So suppose you have to find, so that lower value is basically lesser than the lower range, so it is simply 2 minus of 1. Okay, so think about that. So we're gonna use this. So here suppose we have to calculate for range 2 to 4. So here j is equal to 4 and I is equal to 1. So when we subtract the prefix sum from of fourth index with from when we subtract the first prefix sum of first index from the prefix sum at 4 index, we can get the sum between the range of 2 to the 4. Okay, so that is basically the formula. So here why basically we can get that value, simply think about that. When we calculate for, suppose what is prefix sum 1, so it is simply prefix sum of 0 and that value, that nums of 1. So we simply add nums of 0 with nums of 1 at prefix sum 1. And what about prefix sum 4? So here this is 0, 1, 2, 3 and 4. So we just add all those values from 0 to 4. Okay, so if we subtract these parts like 10 from like this 10, then we simply got that value. Okay, like 20, 30, 40. And if we subtract this like 10 and 20, we can get that value 30, 40 and 50. So why we're going to use to write this concept like prefix sum of j minus of prefix sum of I, and it is simply equals to nums I plus of 1. So I was initially 1. Okay, so it will gives the value from 2 plus 3 plus 4, and that means the value at that index 2, index 2, 3 and index 4. Okay, we're going to add all these values. So why you have to understand that this concept. So here also, now why we gonna use this prefix sum technique in this problem? So here what we have to do, we have to find the subarray sum. Okay, we don't know which subarray is equal to, okay, we don't know which subarray is equal to this sum. So the basic solution, like we can say that the brute force algorithm, we're gonna find all the subarray, we're gonna check for all the subarray, and there we will check if that sum is equal to k or not, and simply we will count it. So there we're gonna first find all the sub arrays, and for that we have to use two for loop. So why its time complexity becomes order of n square, but we're going to solve this problem in order of n time. So before solving this problem, you have to understand prefix sum technique in this way that some books we're gonna see that they are using a prefix sum array. They are building the prefix sum array with an extra index or with an extra element. Okay, so they are just putting the first value as 0 and increase the prefix sum array size. And same way, when we are using this concept, we don't need to write this line. Okay, and for that it should be nums I minus of 1. So why? Okay, this is kind of convention. So for that convention, we simply what we do, we simply create a hash map. Okay, so first understand this is also a kind of concept. So we can use two convention also. So if you are using this prefix sum with extra size, we just put the first value at 0. Okay, at the first index as 0. And here just understand how can we solve this problem using hash map. So simply hash map. What is a hash map? It's a data structure, a map data structure, and where we gonna use the concept, and we stores the data in key value pairs. Okay. So in a Java programming language, you have to, when you want to write a hash map, it's simply a class. Okay, and from a map interface, so we simply implement it. So right now in this problem, how can I use a hash map? So we simply reduce the search part in order of one time. So we can use to write a two for loop. So here understand the right prefix sum minus of left prefix sum simply gives the sum of subarrays. And if that sum of subarrays is equals to k, that means we have to got our value. So we get our value. So here we just simply count it. Also you can write this question in this way. The right prefix sum minus of k should be equals to left of prefix sum. Left of prefix sum. And think about the situation. This right sum and left sum is simply the prefix sum at some time. At some time. So initially, suppose at some time that was the left sum, and right now the prefix sum is different. Okay. So if you think about a single variable, don't think about the index part. So you can understand that at some time in past, that value, that left value has stored in the prefix sum, and again the right value is stored in that prefix sum. Okay, so here if we only check for the right part. That means if you only check for the right part, that means left part is already calculated. Okay, so we simply, what we actually do, we simply check if prefix sum minus of k is it present in the map or not. If that value is present, that means we have already calculated the left part, and that left part is actually at some time it was the right part. So here we use this technique. So what we actually do, we simply put the prefix sum and their count value in the map, and we're gonna start a count value with 1. Okay, so initially the count value of every variable or every values is 1. Simply we don't know what is the prefix sum. Okay, so here we first put the first value as 0, and we count that one, that prefix sum simply. So why 0? So for the second convention, think about the second convention. So when we start a prefix sum with like 0 value, so we can just put that value at this formula. So here you can understand that prefix sum of I is equal to prefix sum I minus of 1 plus num of I minus 1 simply. So here it is simply I minus of 1 equals 0 and plus nums of I minus 1. So for this it is 0. So we're going to start from 1. So simply it is 0. So here for 10, so it is 10, simply it is 10. The same way for this, it is simply I minus of 1, that is of 10, and num ends of minus 1, that is 20. So it's 10 plus 20 is 30. So why we use this concept, and we just put for the zero value, for the zero value we just put the count value is 1. Okay, now but we already used this concept that we have only the prefix sum array, okay, of same size. So for that we have to first write all the prefix sum at 0 index, and also we don't need to write I minus of 1, it's simply I. So here for that situation, why we're going to use this concept? So think about the situation. Here we are checking for the prefix sum, not for the subarray. We have to find the subarray sum, so we're going to use this concept of prefix sum technique. So for that, simply what we actually do, think suppose we have 3, we just got that value 1 comma 2. So 1 comma 2, simply what is that? It is 1 plus of 2. It is simply 2 is equal to 3. So this is our prefix sum 3. So we actually subtract that value from k. So it gives us 0. So that means the first time, when the first time or every time if we encounter that value, that means 3 minus of 3 equal to 0. So if every time when we find that 3 minus of 3, if the prefix sum is 3 and it is equals to 0, okay, sorry, it simply is equal to 0, that means 3 minus of 3, this is the k part, and that's equals to 0. So for that we're going to use this 0. Okay, every time when we find that value, because of we want that it should be equals to, that means prefix sum minus of j minus of k should be equal to k. That means if the first value is equals to k, that means this left part should be 0, must be 0. So why uh, for the right part, when the prefix sum is actually 3, so for there it should be 0. So 0, that means how can we know the count value for 0? So it should be the left sum. So why we have to use 0, and we have to put the map in the map the first value as 0. That means we can get easily the count value of that 0. So why we're going to use this? Okay, and now how can we use the program? Okay, so here we start a for loop from 0th index to n minus of 1, and is simply the num's length minus 1, simply. So num's length, sorry. So here prefix sum is equal to, simply think about that we are not using the prefix sum array. We simply add all those value and we build a variable which actually like store the sub array sum at every time. Okay, so because we're going to use that sub array sum value at some time, so why I'm just going to use a single variable. After that what actually we are doing, we simply check, if that prefix sum minus of k. So if that prefix sum minus of k is the left prefix sum, it is simply the prefix sum, it is simply the prefix sum, but at the left index, at the past. So we actually store that prefix sum into the hash map. Okay, so if that is available, that means this part is also there here. So if that is already available, that means we gonna count it. Okay, so we gonna just count that value. So for that we simply get so here understand this contains key is simply check if that key is present or not. Okay, so here we just check if that prefix sum minus of k is present or not. So if that's present, that means we only check for the left value. So if the right part, that is the left part is already, that means we already calculated the left part. Understand? We already put the value inside the map. So we simply what we actually want to get their count value. So for 0 it is 1, for some value it is another value. So here suppose it gives the value of count is equal to 1. Okay, so we simply increase the count value. And after that, what actually we are doing in line number 37, to understand this, we simply put the prefix sum and their count value. So it is simply calculated it simply put all the prefix sum inside the map. It simply put prefix sum inside the map, and that prefix sum may be, sorry, at that prefix sum may be the left sum or the right sum at some point of time. So it's always here, when we're going to store it, we assume that it is the left sum. So here we just store that value, and if we store that prefix sum, then after we have to also store the count value. Suppose and here the question arises, how can we know what was the initial count value? Suppose some value are already available inside this prefix sum, okay, in that map. Suppose 0, so 0 is already available. Again we encounter where the value 0. Now we want to know what is the count value of this 0. If it was 1, so we simply update with new value and we just add it at 1, so it becomes 2. So if it was 9, so then we're gonna simply get that value and we simply add 1, it's become 10. Okay, so this is the concept. Suppose think about that 3 is not available. Suppose minus of 2 is not available in the map. So if any value is not available in the map, what is that their default value? We simply get their default value as 0. Okay, and we gonna add 1, so it was actually 1. So here this get or default, it is a function, map function. It basically gives you the default value. What default value? The default value you put there at that key value. So it basically gives the default value. So what value you actually write, that is the default value. So we actually take the default value as 0, we simply add 1, so it gives you initial count as 1 if no variable is available inside the map. Okay, and if suppose that variable, suppose here it was already updated. Okay, so suppose think about this -2. So here the value of like count of this -2 prefix sum is 1. So for that we just add that value with 1 and it becomes 2. It becomes 2. So that is the concept, guys. Okay, and here we, every time when we get the prefix sum, that is the left prefix sum, because we have already stored it. Okay, so it will gives the count value, and this prefix sum minus of k is simply prefix sum but at the left prefix sum. So we can say that the prefix sum value at some point of time, what we actually stored in the map, it must be inside the map if that contains key is available. So we simply get the count value from that and we just add in the count variable, and here the count variable basically add all the values and we just simply return it. So this is basically our code of order of one time. How can we get subarray sum with subarray sum equals k? Okay, so you can also use a prefix sum technique with zero value initially. Okay, it becomes like more easy, the problem becomes more easy when we're going to use the zero value at first index. Also you can use this concept, non prefix sum 0 is equal to none of 0. Don't need to use any extra space. So also thanks for watching. If you think this video really helps you, so please do subscribe the channel. Also, what you can do for me, you can share this video with your friends. Also it will really help them. So again, thank you and keep learning.